Welcome again to the SEAM studio, ladies and gentlemen, and this time around, in terms of the Flight Safety Initiative, we're going to talk about the operational error. Now, as we dive into I'd like to start always with something of beauty, and it's very difficult at this stage to say, what is beautiful. But there's nothing more beautiful than an aircraft that is in one piece. Operational error, if I look here at what is operational error, can be viewed as a natural byproduct of human and technology interaction. Now remember that in the shell model, we had the liveware in the center, and we had software, hardware, environment, and then liveware. And the interfaces was happening between the center and each part as we go there. All right. Now remember that the interface between humans, that's obviously the liveware part, and then as we put here on the liveware part with the hardware part. Hardware part, those are the tools that we've got to operate with on a daily basis. And there's a couple of rules. Nonetheless, and during operational activities aimed at delivery of service of any production system. In other words, whether that is a production system when we are going out to fly a sortie, or whether it's on the factory floor, it doesn't matter. It is when man and machine, or liveware and hardware, has to interface. And that, by the way, is the origin then also of human factors. And that's where the term human factors was coined, when we said, okay, but why have we got this interface problem? And the only reason we've got that is because we're human. All right. At this stage, obviously saying that there's no other conceivable or technical reason. The question tonight is, can this happen to you? Now, this is not a takeoff. This is a landing. And once you look at the landing and you look at, the clearances at the bottom, do we come to land without the undercarriage? Now, right from the outside set, it is clear there can be more than one reason why the aircraft hasn't got an undercarriage. Well, why the undercarriage is not out at this moment in time. The aircraft is clearly in landing configuration with flaps down. Now, the undercarriage could be either down, not down, because it wasn't selected down in the first point, or secondly, because it was forgotten. All right. So in both of those cases, error can come to the fore. Obviously, if there's a technical reason, it could be an error that has happened before, poor, shoddy workmanship, or whatever. Or if we, for some other reason, doing final approach, and we don't check that we've got undercarriage, we don't select the undercarriage, and. And that's the kind of operational error that I would like to talk about today. The nature of operational errors, just a couple of points, are accepted as a normal component of any system where humans and technology interact. They say, and operational safety strategies are put into practice to control the operational errors. Well, it says there that it's a normal component, and we've got to make peace with it. In fact, operational errors, there are thousands or millions of operational errors that are made every hour, every day. Humans, we normally err 1 in 1,000 times. So every 1,000 things that we do, there's something that we have an error. It's not something that we want to do. It's not intentionally wrong. It's not that we've got a bad attitude or anything. It is just an honest mistake. All right. Those happen quite a lot. It is statistical fact that aviation millions of operational errors daily basis before a major safety breakdown. All right. In the air they talk once every million recycles, committed develops strong enough to penetrate the system and generate a major safety breakdown. So not every operational error will lead to disaster. It might lead to small deviances, small problems, something that can be handled and picked up, something that not necessarily going to make a change. But that is the problem. Not having undercarriage selected, well, that is a problem. Not being able to select undercarriage, it's a huge problem. The one is that you know that you're not going to necessarily have undercarriage, and the other one you don't know that you do not have undercarriage. And that actually puts you at a greater disadvantage. All right. Nevertheless, mismatches in the interface as with the shell model, and I've just done that. Thousands of operational errors in a daily basis during the course of a normal aviation operations. Okay, so we make a lot of mistakes. These operational errors are trapped by the built-in defenses in the aviation system, and their damaging potential is mitigated, thus prevented negative consequence. And this is quite important. Right from the word go, what is it that in the aviation industry we do to ensure that once we've made an operational error, that we can actually become aware? Or is there something that can catch that error and confine that error and limit the consequence of that error? And that's basically one of the things we have to talk. In other words, operational errors takes place on a daily basis. Effective performance, obviously that will affect the defenses. Well, defenses are the one thing that we've got to right, and then the last one that we're looking at here, it says, in other words, control of the operational errors takes place on a daily basis through the effective performance of the aviation system. Oh, that is a mouthful. It means that even though the system is effective and that we've got the right stuff going and, it is very difficult to have any flight operation or procedure without small errors creeping in. And this is what we want to talk about. How do we, oh my goodness, here we've got a little bit of a problem. We can see, obviously this is a wheels up landing. Now right from the word go, I must say, I don't know whether this was forgetting to select the undercarriage or whether this was the undercarriage that couldn't be selected. But for now, there's a couple of things on the photograph that I just want to point out. Well, first of all, it's quite clear if we point out that, all right, we haven't got undercarriage. From this picture, it's not very clear to see, but if I look at the shadows at the back there, it will probably indicate that there might be flaps down. In other words, the aircraft was in total landing configuration except for the landing gear. Now, whether that was forgotten or it couldn't be put out, as I say, I don't know. But let's look, what does the props tell us? Now, the props are bent rearwards. In other words, the acceleration was this way and the props are bent the other way. The moment that you see that on a prop, it means that there was no power on that prop. The prop wasn't cutting and grabbling forward. And just now I'm going to show you a picture where the props have actually bent to the front. And that means there was a full amount of power. So it's safe to say in this case that both the engines here had zero power on them. Another thing that we can see is that they were not feathered. Right, and people say to me, but what's the feathering got to do with it? Well, you see, if I know that I have got no undercarriage and I'm going to have to land, then I will probably put myself in a pretty convenient position, and then I will take the engines offline and I actually will feather the engines and kill the engines completely so that there will be minimum damage. In fact, when they're feathered and they don't turn anymore, then at worst case scenario, probably we will have maybe one blade or so damaged. And remember, because the engine was not running, it makes a huge difference on the shock load that the engine had to take once the prop hit the ground. If the engines were just in idle, remember, they're still in idle, they're turning and they're working. So it's just a little bit that I can figure out here. What else we can see from here? It's a beautiful day. People got out, nobody is hurt. In fact, if you look at the center line, if you look at the scrape marks at the back there, one will actually see that this was quite a good landing. Okay, now, you know this thing about superlatives. I also had to go and ask again, what is this good, better, best, and bad, worst, I don't know, very bad, whatever. But those are superlatives, and I thought it probably apt at this stage to look at an error. What are the error superlatives? Where does the error start, and where does it go from, let's say, from bad to worse, to maybe terrible or whatever the superlative would be in that sequence? Start off with the error. Now, the only reason that I've got a hole in the center there is to show that the error was not captured. In other words, there is an unintended mistake. It's, in other words, not really a transgression. We just forgot to put the undercarriage down, okay? Give me a break. Undercarriage not selected before landing, and that put the aircraft into an undesired state. Or then the undesirable state of the aircraft is now initiated. Right, so you're sitting on downwind. For some or other reason, you got distracted. I don't know what you were doing, but you just simply didn't select the undercarriage down. You did the rest of the power settings. You put the flaps down. You did everything. You didn't notice that the aircraft was performing a little bit better than normal, because you didn't notice that the less drag of the wheels actually made an inch or two manifold pressure difference. You didn't notice that it made a speed difference, and. You didn't notice that you actually used less power. In other words, you are now totally still unaware. Now remember, the moment that the error is made, then the error goes into a latency state. In other words, it's lying there dormant. It's not shouting at you, not yet. Because remember, having not selected the undercarriage down, and you didn't check for the green, and you didn't check for the mechanical reason it's down, or outside in the Baron's case where there's a little mirror on the wing to say if the nose gear is out. By the way, all these things are taught. But somehow, for some or other reason, everything slipped past us. And you'll say to me, is that duh? Is it possible? Well, unfortunately, once you take somebody's mind and you bend it and you can capture it to a certain level, then in the peripherals, things will not really matter anymore, because you become so focused on that one specific thing. And this is obviously where one of the key problems. The next thing is the error is now undetected. How do we detect errors? Well, here you can look. I said the checklist failure. Remember that we use checklists, SOPs, not little rhymes. We've got sequences of doing things, and we hammer it into the heads all the day. Every time that we fly, this is what you do. On downwind, the first thing is you do your radio call. The next, you set the power. The next, brakes, undercarriage down, and wait for it. Cloop, cloop, cloop. 3 greens we've got. Check. Outside indication, green light, mechanical indication. And now you carry on with setting the mixture, the pitch, the throttle for the condition, and. Right. So there's an absolute sequence that we follow. It's not a sequence that we follow maybe now and then. Flying does not work like that. The moment that you fly and you do not follow the absolute sequence anymore, you're looking for trouble. What makes you so good? Well, all right, never mind. Checklist failed. In other words, if we didn't use, now the aircraft is definitely in an undesired state, and it's now in a fully fledged, or it's getting into the undesired, it is now in the latency state. It is now there. Your first time you made the error, the second time you compounded the error by not picking it up due to the correct procedures, and then the next step they say, but you amplified the problem. What is that? They say there is a possible consequence that is increased. Whoa, how's that possible? You talk here about unheeded. Whoa, unheeded warnings. Now, it simply means it's a warning that came into the cockpit. For instance, the red light that is showing for the undercarriage is an unheeded warning because we didn't pick it up, and the warning is there. Maybe the undercarriage horn is blowing, but you are so distracted that you actually don't hear it. And don't even think for a moment that you were created above that kind of mistake. It's simply not true. It is easy to distract someone to the point where they can, in their peripherals, as I already said, not see or hear, but they are so focused on that which is seemingly important at that moment in time. So I said it is ignored, and the aircraft is now in a solid, undesired state. Still, if you then look right through, it popped through that hole, it popped through there, it didn't stop there, and the things that could have stopped it actually now compounded the problem even further. There's now a certain amount of inevitability to this. We are now on the final approach. We do not see that there's anything wrong. It is undetected, and on we go, and it's now amplified to the level where, remember, at this stage of the game, there's been no consequence. There's been, in terms of flight safety, on downwind, on base lag, on final, there's still the problem is when you're going to make contact with Mother Earth. So now we just hope and pray that somebody's going to pick up that the undercarriage is definitely not down. I'm not one of the guys that's listening to the clips on YouTube where you can hear the hooter screaming, but both people are so mesmerized by something that they don't see where they're heading to. All right, just to get a little bit off the technical side there, I said I will show you props that bend forward, and here you can see that they bend forward. That one is bent rearwards. In other words, this prop, when it struck the ground, the power was gone, there was no more power, and probably, but here you can see it's like as the engine turns, and it, like the prop, when it hits something solid, remember, it wants to take air and take it to the back. But when it hits something solid, it cannot move it to the back. And remember, the body is still moving forward, and that blade simply moves forward. So in this case, from an accident investigative point of view, I can tell you that there was a phenomenal amount of the right-hand engine had power for quite a long time, and the left-hand engine, or the number one engine, it's a little bit of a time that it is just at the point, either the crankshaft broke or something, but there was no more power on the prop in that case. All right. If we look at reasons for the error induction, now please, this is where we've got to pay attention, because this is exactly the problem and how it's going to be. Distracted attention. And I can tell you now that distracted attention is the number one. Distracted attention is number one. Where must your attention be? Well, at the things that you need to do. What do you need to do? Well, all the calls according to the SOPs. And that will be your checklist, and. Yeah, but Charlie, I'm flying a single aircraft. I don't, it's dangerous to read this checklist, man. You know, I can't read and fly this thing at the same time. That's fine, but what are you doing at that stage? How ingrained is it up here? What must I be busy with? And if I am interrupted by the tower, by another aircraft, by a passenger distracting me, or whatever, if there's anything that takes my attention away from the procedures, what do you do then? You start right from the beginning. And by the way, I've said it many times, but please do your procedures out loud. Because if you do it out loud and you can hear it on your mic, you are listening to yourself. And when you listen to yourself, oh yes, by the way, some people get it right, but it's unnatural for you not to hear what you are saying. And that's why this mustn't be a rhyme. Because you're just saying, undercarriage down, blah, 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 blah. Then, blah, you're in the ground. Okay? So be very careful to make little rhymes out of the things. Not following the SOP. And a lot of people say, why? The guys don't follow the SOP. Well, it's probably not that they really don't want to follow it, but it's not become second nature. No second nature development. There's no subconsciousness embedded that will take automatic. You know, it's even today in the Harvard, if you wanted to, after takeoff, to get the undercarriage up, you would apply the brakes, and then you would have to energize. You had to push down a lever to energize, to get hydraulics into the system, and then undercarriage up. So even today, when I sit there after takeoff, brakes, energize, undercarriage, I say, energize, where does it come from? Man, it's 1,800 hours on the Harvards that ingrained that into my... And it's difficult for me, after takeoff, not to say energize. It's just ingrained. Now imagine, this luckily is something that is extra, that's ingrained as a single pilot. In a multi-crew, we do call-outs, we do checks, and we run, well, we don't let it over just to memory. But in this case, memory is what is happening. Skipping the flight phase. Ooh, okay. Now, what is the flight phase gate? Okay. You know, when we approach an aircraft when we approach a runway to land, there are 3 places that we normally join. Obviously, there can be others as well, but okay, let's make it 4 for now. And the first one that I will say to you is that initial. Now, what is an initial? An initial joining is when you join overhead at 2,000 feet above the ground. You check out what the runways are in use, and from there you then descend and you join the circuit. And the initial. Initial is not something that we use anymore. Well, but what is the unmanned procedure anything else than actually flying an initial? You're flying overhead, checking what it is, and then joining into procedure. All right, so there's the initial, there's downwind that you can join. There is base leg that you can join, and there's the final approach. Now, the initial, the downwind, and the final, those are pretty normal for people to join in those different places. The thing in your mind is, then when you join to land and you're in a certain place, it starts coming something that just pops up naturally to say, right, and you start your radio call. Where am I? And immediately, the radio call triggers the brakes on and off. Undercarriage selection down, stand by, and wait. And you follow through the procedure. But there is that trigger. Where is that gate? Now, when we fly in the school environment, or when you fly in a controlled airspace environment, then normally you will join a downwind. And in an unmanned procedure, you'll probably join overhead, and then you will put yourself on a downwind. So downwind in both these cases, they're there. But in many, many times, I mean, an airline, or under normal circumstances, we're not going to fly a downwind and a base leg onto final if the flight path is actually taking us straight onto final. Because time is money. So now all of a sudden, we're used to the fact that we're joining a downwind all the time, and all of a sudden, we're not called to do a downwind joining, but a final, straight in approach. Oopsie. Now, there's a different flight gate. The flight gate is not initiated by a downwind because it does not exist. So, your pre-landing procedures, now it is not downwind procedures anymore. It is now pre-landing. So we keep on teaching going into land, there's pre-landing. But in ordinary cases, we've got downwind checks, we've got base check, we've got final check. And here you've got one long final to do your preparation to land, the checks that you normally would have done on base, and the checks you've got to do on final, and you do that in a straight line. What I'm saying is that it has changed the mindset. All right. So can you approach in different places? Yes, of course. It's not a problem. But it doesn't matter the time. That gate must trigger so that you do the right things at the right time. Then I said here, deviate from the planned sequence of events, and the impromptu deviations for an adrenaline kick. The moment that you think, I'm going to do a shoot up, and I'm going to just be the man, your heart is starting to pump. There's adrenaline pumping into your veins. And what happens to that adrenaline? Well, let me tell you, it makes you stronger, but it is overwhelming you, because there's nothing that can happen to that energy except to turn into some kind of toxin inside, because you can't quickly run out of the way. But as you say, okay, we're going to do a shoot up, the heart is starting to pump, everything is here, and the excitement is growing, and now you're going in, and as you go in for the shoot up, that is when you actually become deaf and blind to anything in the peripheral. That is what unplanned stuff does to you. Yeah. Okay. Oh, okay. This picture here, just notice now, here you can see these props are standing still basically, and they are feathered. So, what is that, a 210? In this case, we know that the guy hasn't got undercarriage, engines are now closed and feathered, and this guy, in all possibilities and probabilities, knows that, man, I've got no undercarriage and I've got to prepare the aircraft. Now just note here that this propeller stopped in a very, very ideal position, and this one, obviously, that blade is going to become damaged. But because the engine is not turning, there's not going to be conceivable any really shock load on the engines. Okay, that's just something. I don't want everybody to go and cut the engines now. Air capturing, let's have a look at that. Man and machine interface needs help to avoid the mismatch. And there's three of them. The first one is technology, standard operating procedures, and training. And you'll say to me, Charlie, but you're repeating it all the time. Well, look, we make the errors. And we've got technology. And we start trusting in stuff so that eventually it is the machine that must do the procedures. And we just become a sort of innocent passenger. Well, if you pilot on your own, you can't become an innocent passenger because it just doesn't fit the picture. But let's have a look here. Technology. There's an audio system, normally voices or tones, warning lights, steady flicker or color, stick shakers, input denial. This is one of the things that happen is if you're out of sequence, the system just won't accept the next step. It is like if you select the flaps down above a certain speed, and some of the aircraft would have the equipment to say, okay, speed is too high, flaps will not come out, and as the speed bleeds below the flap maximum speed, the flaps will start deploying. That's an old trick for the fighter guys. They whip down the flaps, they know nothing is going to happen, and as they come down, the flaps start deploying. Okay, so there are those things. It's not to say they're going to work. Here is the thing. You must keep, you know what? Yeah, I've got to get a red pen. Keep your technology serviceable. Snag and fix. Snag and fix. Listen, you cannot decide after a sortie not to write up the technology problems or failures or whatever. If the undercarriage horn is broken, there is nothing to amplify the bad situation, and therefore the actual error is being amplified. Not an intention grabber. It now turns against you. So by not properly snagging, let's say the undercarriage hooter, all that you're doing is you're waiting for a place where you're going to end up with no undercarriage warning system, and if you get into that system, the inevitable must happen. Remember that we're saying that last one is, this is where we need to pick up something, because we cannot get into an undesired state in a solid state. We don't want to be there. Well, if this thing doesn't work, it's not going to help you anymore. It's like the undercarriage lights. How do you know the undercarriage is done? How do you know how much fuel you've got on board? No, I checked. Well, did you get a leak? And I don't know. All right? The fact is, that is why we snag stuff. And that's why we fix stuff. All right. And then I say here, before flight inspections, ensure equipment date serviceability and. Guys and girls, before you're going to fly, there's this thing that you've got to open. It says, okay, there's the CFA, there's the radio license, all that kind of stuff. The MPIs was done, and the aircraft is still within the hours. That must be done each and every time. Yeah, but I thought that the undercarriage warning did work. Well, you didn't see that it was snagged. But you also didn't pick up that it wasn't fixed. Well, now we've got problem from both sides. Remember, I said that the technology, how will you know that it's not serviceable? Well, somebody must tell you it's not serviceable, and that somebody can only tell it by writing it down. You will only know, if you're the next person to fly the aircraft, if you see that. That is why we go to an aircraft and we do a pre-flight, and anything is wrong on that aircraft, there's damage or anything detected, it is blamed on the guys before that sortie. Every time. Yeah, but I don't know if that problem existed for the past 15 hours or 20 hours. It doesn't matter. The fact is that I picked it up now. So the only person that I can hold liable for it is the one that last flew the aircraft. By the way, that's why we do afterflights. And don't think if you pick up on an afterflight that there's something wrong. The next guys won't pick it up on the pre-flight. You're just damn lucky if they don't. All right, and it could then be blamed on. Then it's going to be blamed on you because you're the next one that's going to fly. A little bit of a problem, eh? SOPs. Now, the capturing we've got through technology, but remember now we need SOPs. SOPs must be developed for the phases of flight. It must dictate what, where, when, and how, and the SOP must be enforced. Now, I just want to put this here, because who enforces the SOP? Really, am I sitting there and every sort of looking over your shoulder, what are you doing? Oh, come on, I haven't got time for that. Eventually, you're going to have to be on your own. And if you cannot enforce doing the right thing by yourself, you just became another rogue aviator, all right? And you will pay for it. I promise you. Few to no people walk away. There are certain things that, look, when we teach people how to interface with machine, why do we do procedures? Is to avoid interface errors. Why do we do procedures on baselec again? To check up if we did the downwind. Why do we redo the final checks? To check that we've got the undercarriage, we've got the flap and everything. Why? Because we're following the SOP. We check it. What is that to do? That is to capture. But if you do not follow the SOP cannot help you. It cannot help you. It's meaningless because it's something on a piece of paper. I can give you the piece of paper. I can teach you to use the piece of paper, but I cannot force you to use the piece of paper. Training. Train, utilization of technology, train-related paperwork of technology. When do we apply the technology? Indicators when the technology has failed, how to function without or with limited technological support. So if I haven't got undercarriage down, it will mean that the power settings that I'm used to will now be too much for the normal speeds. There's a deviation. So I need you to get into the cockpit and start observing exactly, if you fly the same aircraft, the same type of aircraft all the time, if I set this power setting, what is the speed do I get under certain configurations? These with flap downs, these with undercarriage down, and. What is it that we get? And then we use that as baseline. The moment that we know, in other words, we've got pre-knowledge, and we say, hey, this is strange. Normally, I need 22 to 23 inches to maintain, let's say, 90 or 85 miles per hour. But all of a sudden I see, wow, I only need 20 inches or maybe whatever the case might be. That is where we've got the problem. All of a sudden we need less. Then there's something different. Because drag will result, or the drag that you have got at that moment in time will automatically lead to how much do you actually need at the end of the day. How much power. Just to come a little bit more to a positive there, we are okay, so next we're going to have a look at the superlative or the antidotes. And, well, as I've said, first of all, remember that there was the error phase, then there was the undetected because the checklist failures, and then the amplification by not looking and not be able to pick up that we had warnings. So unintended, checklist failure, and the consequence is now increased. The consequence has increased, or the possibility of the consequence has increased, whichever way. All right, so now remember the antidotes that we're looking at, the secondary indications of an aircraft undesired state, such as speed, power required, and. And I've said quite a bit of that now. If these secondary indications will trigger that to you, then obviously it'll bounce away and the sequence will stop there. But let's say it checks through, but now you get the checklist. It's ingrained, it's practiced, it's applied, it is all over the show. And if you now apply it, you pick up, oh my goodness, I haven't got undercarriage, whip it down, and everything stops there. Now, in the last case here that we're talking about is where we say, all right, that router that I snagged and is fixed now, that hooter started blaring in my ears, and the red light shone in my eyes, and all that. And I heed to the warnings, and it stops there, and the result is as expected, a good end result. Is it really as easy as that? Because remember, here I say, you've got to train, you've got to work your SOPs, and you've got to have your technology. Now, where the technology is going to come in is here. The SOPs will come here, but where do we start to do or let's rather call it then error capturing skills is under the training. It's in this case. All right, I know this thing is so full of blobs here, so I can just do that, and voila, it's ready again. And okay, so technology, but if technology fails you, then you can't go beyond that point. So now all of a sudden, the SOP is actually the only key here between the error and the expected end result. It's the SOP. Yeah, but we haven't got SOPs. Then make SOPs. Yeah, but this. Stop yeah-butting. All right? The fact is that get your SOPs triggered, do the SOP, get into there, because that is to save the day. How do we get that ingrained? We learn, we teach, we enforce, and then we wean you, and at the end of the day, we leave you. And then, hopefully, you're not going to screw it up. But what will lead you to disaster is to not follow the recipe. If you want the same chocolate cake, you must use the same recipe every time. You cannot get into the madness loop to change the ingredients and hope every time to get exactly the same end result. Or, alternately, as our clever learned friend said, who discovered this E equals MC square, when he said that you have the same ingredients but you expect a different result. It's not how it works. Ingredients equals results. Period. Yeah, but I'm better than you. It's got nothing to do with you and I. Whether you're better than me, that's fine. I accept it. You're better than me. All right. But none of us are bigger than the moment or the SOP at that specific point in time. Oh, okay. And there in the back, I think I recognize Leonard Hawkins there. Conclusion. All right. So, well, let me get it here. Operational errors are an integral part. We now know that. Errors will occur. Errors tend to leave latent aircraft undesired state. That is a fact. All right. Up to now, you make an error. It's an honest mistake. All right. It's going to happen. It's just the natural world that we've got to interface with, and we're going to end up as in an undesired state. The next reality is that the error is normally as a delayed effect, or its relevance is delayed. It's not to say that it's going to happen right now. If I don't put the undercarriage down, nothing's going to happen right now. It's going to happen by the time that you get at a height that is lower than where the undercarriage normally would have touched the ground. Not much lower. Maybe that much lower. Then the propeller's going to start eating. Okay? So, error capturing. And that is why up to that point, that will happen. That is bound to happen. No amount of training, no amount of whatever can basically stop that. But how we capture our errors and how we become aware of our errors, that is the key. All right, so let's look at error capturing. And there it says, must be practice, irrespective. So whether you suspect an error or not, you do the error capturing. And error capturing is the easiest if it's from no technological, and remember technological we said is the last phase, the error is the first phase, and in the center we've got the thing that can help us in the center to make it or not make it is the SOP. I think by now you should start getting that sort of understanding. All right, then must know how to apply, must know the limitations of the technology, and here, I just want to put this in red again, the checklist is not a rhyme. It is a reasoned response. It's a reasoned barrier between error and fatality. Well, eventuality. It doesn't have to be fatal. But the thing that protects us in the center. So yes, we can put in all the technology in the world. So you had the best radio altimeter, but you were never taught how to use it. You never were taught what was the standard operating procedures of utilizing and when and where and how to utilize the radio altimeter. So when you started doing your low flying over the dams, you touched the water and that was the end, and now you are dead. And now everybody has got one hell of a problem. And then I say to him, guys, remember, there's a reasoning behind this. You must know how it works, when to work. So we've got the technology, but before we can use it, we must be capable. We can't just be capable in each and in any or every way. We must be capable to use it according to a specification. Listen now. You can't wait to say if all else fails, then you are going to fail. Because in flying, it's not then the time to discover, oh my goodness, maybe I should have. Those are normally the last things that might go through your mind before something else goes through your mind in a quite gruesome manner. All right. Am I trying to put this operational thing and the error in a negative phase? No. Get used to it. The operational error, the interface error between man and machine, the interface error between liveware and hardware is going to be there. Period. Get used to it. Suck it up. I nearly said use it or lose it. I don't want you to lose it, because that's why we're talking to each other. But this must trigger your mind to say, all right, now we know the errors, and how do we capture errors? How do we oversee ourselves? And the primary one will be the SOP. If you follow the SOPs, you'll also find that your technology will help you in a big way. But if you do not use the SOP and you solely rely on the technology, you might get a nasty surprise. Now, the whole idea about flight safety is not to scare the whatever out of you. The idea of flight safety is for us to get into a place where we can actually enjoy flying. So, I'm going to do an aerobatic sortie. What do? No, I do Hazel checks. Really? Yes. When? Every time. And then? Well, then I enjoy the aerobatics. But I know the aircraft configuration is right. I know that the settings are right. I know. I just don't bomb in there. I've got my ritual that I will go through before I do that. Before I go to land. Before I go on a navigation. Before I speak to the tower. I've got all that. What is my golden guideline? Standard operating procedure. You must know your procedures. For you guys out there that there are no procedures, make them up. And then use them. Make them work for you. A lot of people say, no, but we haven't got the SOP. Okay, Now you know that you don't have it. That is the best time to start to create it. Yeah, but it's not my job, you know. I'm just a worker here. Really? So because you don't want to do something, somebody else or yourself, it's okay. Somebody's going to get hurt. You're comfortable with that because I'm at this level. Oh, come on, give me a break. Really. Take responsibility. Until next time.